Okay. Good evening, all. Today we will learn.
Good
Today we
evening, sir.
will learn regarding the assembly and corridor, how to create assembly and how to apply it to the alignment that we will learn today. Is it my voice is audible to everyone?
Yes, sir. Yes, sir.
Okay. I will share the screen.
Clear.
Now the screen is visible to everyone.
Yes, sir. Yes, sir.
Okay. Yesterday we seen regarding the vertical alignment, right? How Sumit curve and Valley curve will be given to the vertical profile that we learned yesterday. Today we will go with the assembly known as cross section of road, and corridor we will learn today. Okay. Uh, Yesterday I have done some few curves only. Today I have done all curves. You can see I've done all curves, added the Sumit curve, Valley curve to the
सर
all.
आपका ऑडियो नहीं आ रहा है।
ऑडियो नहीं आ रहा है?
ऑडियो तो आ रहा है।
Check with your laptop. You can see I have added all curves, Sumit curve, Valley curve, total. You can see is all curve. For seeing what are the total curves, click on the profile, select profile. In this, you can go in the geometry editor. Click on geometry editor. Click on the geometry editor. Go in the, you can see it is a green icon, profile grid view. In that, click on that. You will get all the curves. What are curves provided on the vertical profile? You can see this is the first one. There is a sag curve. Second also sag curve. Sag means valley curve, and crest is a Sumit curve. Right? You can see these many curves are provided along the alignment, having their k values. You can see these k values. Minimum k value is a 73.6. We provided larger than this. You can see these all curves are provided along the alignment, along the vertical profile. Right now, we will move to the assembly. For assembly, uh, you will go in the Home tab. You can see there is a assembly icon, right? Click drop down icon of assembly. Now click to the create assembly, right? After clicking on the create assembly, it will ask to name the assembly. Now I will provide TCS, typical cross section, greenfield. I will name it as typical cross section greenfield, right? It is an undivided crown road. Now assembly style, it is SSDCPL. As template is set already, it will come automatically. And code set style will be all codes. Then click OK. Now it will ask to define the point where you want assembly. Right click any point. You can see this is a assembly point known as a center point of typical cross section. Right. Now we will draw the pavement crust and the shoulder drain that we will draw now. Right now. For that, in the Home tab only, there is a tool palettes, right here. You can see this is a tool palettes icon. Click on that tool palettes. It will open another vertical bar. You can see this is a vertical bar. This is a vertical. They are having many tabs in this. You can see these all tabs are there in the vertical bar of tool palettes. In that we will majorly use what that I will tell you. In the lane tabs, you can see there is a lane tab, right? Now, first of all, we need to create the median. We will go in the median tab, right? In the median, you can see in the median, there are many types of median are there. Right now, we will use median constant slope with barriers, right? There are two barriers at the edge of the median, and there is a median slope, median fill will be there, right? I will click on that. Now it will ask to select the point with the assembly, right? You can select the center line of assembly. It will take the median, right? You can see median, it has having a median, and there are also layers on the right and left side also, and there is a bottom curve. You can see for this, seeing what the elements are there, you can click on this, then go in the sub assembly properties. You can see in the parameter you will go sub assembly help here in the bottom corner of right bottom corner. Click on triple dot. It will give the all elements which are elements used for the median, right? You can see these all elements are there, right? There is a crash barrier at the top. You can see this barrier height. Then bottom is a optional key width. It is a key, optional key depth, optional key width, sub base, percentage slope. This all you can learn. It is a simple one. Only right now what needed I will tell you. In this, go in the parameter. Now the median width for the expressway, it will be goes around 12 to 15 meter in the expressway, but many due to land constraint many express will be is deviating the IRC code. It will provided with the median of 4.5 meter as a median, right? Now the left width of median, it is a 2.25, and right width it is 2.25. Like that it will become 4, right? In the barrier width, I will kept at it as it is. Then I will remove the key, right? Key is not needed. That's why I'm removing key, making all values of key related to 0. Now the pavement also is not needed in the median. That also I will making 0. Only median filling will be there, right? Extension also I will making 0. I will making all values related to pavement 0. Right? Only we need the pavement one depth as a 0.5, right? Median filling I am kept at it is as a 0.5. Right now, click apply. No, no, it is taking the percentage sub base slope will be 0%. Click on apply. You can see the changes in the right window. Now I done the sub base shoulder. Barrier width I will keep that it is. Shoulder width, right shoulder width 1.2. I'll make it is 0. And don't need the shoulders in the median. I'll making 0. right? I need the pavement depth, right? Or the filling that I will give uh, median, that is around 0.15. Can see I will go in the options. If you can't get anything, go in the options. Help, help, click on the help. You can get all the things, right? The subbase percentage slope will be 0%, right? And there where is the depth? You can see the depth you can give shoulder width 0.5, optional key width I make 0, subbase width making 0.5. Can see it is a trial error. By saying the subassembly elf, you need to add the things. Shoulder width, right shoulder width 0. What we need to add it is there is no vertical height. The pavement itself we need to add 0.5. Left pavement we add 0.5. In the right pavement I will add 0.5. 50% it is 0. Like okay. Now you can see the median is formed. It is a trial error. By seeing assembly help, you can create the median. Right now the median is done. Can see the below is median filling, and then above it is a crash barriers. Right now we will add the lanes. Right in the go in the lanes, in the lane you will select the lane super elevation AOR. Right, select lane. It will ask to give the point of where to kept, that it will ask. Select that point. You can see the pavement now it is done. Now our case, it is a 6-lane expressway with 4.5 as a median. I will change the width all this. Select on that. Select only single and click on subassembly properties. Go in the parameter. Right. It is a side is right. Width I am giving. Now it is a 6-lane. Then one lane width according to SP99 expressway code, it is a 3.75 the lane width. Like that we provide 3 lanes. Then it will equals to 11.25 plus 3 meter paved shoulder. Right, all widths will be taken right here. That is 14.25. Right, the default slope for the now we providing the that rigid pavement, it will be -2%. Pavement depth, first I will consider PQC as a 0.3 and DLC as 0.15. and GSB as a 0.2 and subgrade as a 0.5. These all layers regarding the layers in the rigid pavement. First lecture I explained this all, right, in the uh, pavement, rigid and flexible pavement. I already explained what are the layers, right? Like that we will take, and we will use super elevation, right? Use super elevation. It is a right lane outside. Select right lane outside, right? It is right lane. We will select right lane outside, right? Click OK. Then apply, click OK. Now you can see the right pavement is now, right carriageway is now there, right? We will add shoulder to this. You can see the in the shoulder tab, in the tool palettes only, we are using all the things. You can see in the shoulder, select the shoulder extend all. It will ask, then same select the point. You can see the shoulder now created. I will change the things, parameters of that. Now the shoulder width will be 2.5, and now I am using super elevation. It is a right outside shoulder, right? It is a outside shoulder. We'll select, and the slope will be for the shoulders. It is a minimum 3%, or slope of carriageway plus 0.5. Now in this, the slope will be for the carriageway it is 2% plus 0.5. It will become 2.5, but the minimum it is 3%. So we will giving 3% as a shoulder slope, right? Daylight slope. Now you can see there is a daylight slope in the sub assembly. You can see the sub assembly help will only active when there is a internet connection. If there is no internet connection, we can't see help, right? In the, you can see daylight slope is the slope of layers, right? Now generally we provide 2:1 as a slope, two horizontal, one is vertical, like that. Then sub base percentage slope will be 3%, same as above. Now in the shoulder we will provide only, first there will be sub base throughout, that is subgrade will be throughout, GSB also throughout, and we provide DLC as a 0, DLC as 0, and there will be earthen filling that we will give in the pavement 1 depth. Now it will become zero point 0.3 plus 0.15, it will become 0.45, right? Top 0.45 we will giving the earthen shoulder, and there will be GSB and subgrade, like that will be there. Now click on apply, click OK. You can see shoulder, now shoulder is ready, median, lanes and shoulder. Now we will giving the earthen drain, right? For earthen drain, go in the generic, right? For generic, there is no perfect shape of earthen shoulder. That's why we will develop the with the help of generic. First, in the generic, take link width and slope, right? In this, click on that, select the marker point with the assembly. Now you can see there will be the first, there is a berm, right? In the sub assembly, we will provide berm as a 1 meter, and slope all this okay. Then click OK. Slope will be 0%, right? Perfectly horizontal berm will be provided after the layers. Now we will same, select the link with slope. We will take same. Now we will give the slope, right? For the slope, we will select same sub-assembly properties. I will select it is 1 meter, width will be 1 meter, and the slope is a 50%. Now it is going up. We will give negative 50%. Can see now applied. Can see now drain portion as now one portion of drain now done. I am making the drain. I will show what I am making. Now this type of drain, earthen shoulder I am making right now. Right now, one slant edge I have developed. I will give percentage as a 0.45. 45% angle will be there. No, it will be minus 50%. I will increase the width. Right, based on the dimensions, you will give these all things. Now, I need more slope. I am giving 75 like that. I am giving the slope. Based on the drawings, typical cross section, you will give the dimensions of the sub assembly. Right now, I need the horizontal link. Same, I will took the link width and slope. I will give same. Right now, I will modify the properties in the sub assembly. Right, bottom width will be 1 meter, and it is having a zero slope, perfectly horizontal. Click apply, click OK. Right, now I will copy this. You can copy anything. Select on that. You can see the bar, horizontal bar will be available for related to that. Copy things and paste where do you want. Now I need the slope above. I'm making the parameters change. Now I will remove the negative. You can see it is now up. Right, after that, we will provide the ground slope. Right, for the ground slope, we will go in the daylight. In that, we will see, we will select the daylight general. Click on that. You can see now the slope will be done. Above is cutting slope and below is the filling slope. Right now, we don't know where the cutting, where is the filling. For the individual, there is a changing according to the chainage. Will be cutting or filling? Right now, I will see you. Here you can see there is a cutting, and afterwards there is a filling. Right? We don't know exactly uh, each chainage. We can't apply the TCS, so we prepare for the general. Right? In the general TCS, that is typical cross section, we will give all the things in that only. Can see in this, we will giving the cutting and filling slope. For modifying the properties, click on that. Click sub assembly properties. You can see parameters. Now you can see for the cut slope, where flat cut will be there the slope will be 2:1. If median cut will be there will be 1:2 slope will be there. And if cut is a very steep, we will provide 0.5:1. Like that, we are depending according to the depth of cut. Like that, for the filling also, for the flat filling, we provide 2:1. These all will be standard things. You need to go with this. And steep gradient, steep fill, medium fill, and flat fill. There will be 2:1 only for the filling. and cutting their first uh, in the flat cut there is a 2:1, in the median cut it is 1:1, and for steep cut it is 0.5:1. Then click apply, click OK. You can see it is already taken in this. Right now we done right side all carriageway related. For left side we will mirror this, right? Select all, go in the select all, and you can see there is a mirror icon. Click on that mirror and select this point. You can see now a mirror is done. This is known as typical cross section. You can see we have given 2% slope for the pavement and 3% slope for the shoulder, right? This is known as camber slope. This is a standard slope according to IRC. For the flexible pavement 2.5%, and for rigid pavement it is a 2%. Like this we develop the assembly, right? This all total is known as assembly. This is assembly. Right now we will move to the corridor. Corridor is simple. Same in the home tab only. You will go, there is a corridor tab. Select drop down, click on the corridor. Now this pop-up window will open. In this, you can see in the right side, we will select the alignment. Alignment is a Nagpur Goa center line, and profile will be design profile. We will assign corridor to the design profile only, right? And then assembly will be, right now we done the modeling of assembly, that is TCS greenfield, typical cross section greenfield area. After selecting all this, we'll give target surface. You can see there is a target surface. For the target surface we will give target surface as a existing surface, right? Okay, then click OK. Now it will you can after clicking this pop-up window will open. In this you can see the start chainage, end chainage. This is a start station and this is a end station. You can apply many number of TCS. Now I am applying single TCS to the whole length according to the cut fill. Where when there is a cutting the TCS will be different, when there is a filling the TCS will be different. Likewise we need to develop all typical cross section as assemblies, then apply according to the chainage wise, right? You can, now I am applying 0 chainage to 5140 total alignment I am applying, right? Click on the apply. It will ask to rebuild the corridor. Right click on the rebuild the corridor. It will model the corridor. You can see in the right bottom it is modeling. As the length is more, it will takes time. You can see now there is a in the alignment we found only the center line, right? After modeling it will give the all the dimensions, that is pavement, shoulder, and the ground cutting, filling, that all will be now visible in the alignment. You can see the alignment changed right now. You can see here the central one is a median, and these or the from this to this, you can see this is a central one is median, and there is a left carriageway and right carriageway. Thereafter, there is a shoulder. After that, there will be the ground slope of layers, and there will be cutting and filling. Like that, this is known as corridor. Now we done with the corridor. Uh, Wait 1 minute. It's taking time to reload. When we do modeling, it takes times, queue time to Civil 3D to reload all the things. You can see total corridor is applied to throughout length. You can see at the end, like in the middle, you can see this all the corridor. You can see total there is a filling only. That's why it is going beyond the width of the shoulder. Right now, the green uh, endmost line of green. Can see this is a typical cross section. After that, there is a cutting filling slope. This all it is a filling slope. Here you can see these all filling slope. You can see first there is a cutting, right? Can see now you can see here there is no filling slope, right? Like this, we will model the corridor, and this was assembly, right? Uh, this is for today's class. We Main function of modeling corridor and generating assembly is to take up the quantities of earthwork. How much earthwork cutting filling will be there? That will be calculated based on the corridor only, right? For generating a quantities, we need the corridor, right? This is total today's class regarding assembly and corridor. Uh,
अच्छा कॉरिडोर का स्टेप रिपीट कर दीजिए
yes,
कॉरिडोर के स्टेप रिपीट कर दीजिए
corridor.
हाँ yes sir.
Corridor is simple. We'll go in the home tab. There is a corridor. Click on create corridor. Then we will select the alignment and we'll select design profile and assembly and will give the target surface as existing surface. Then we'll click OK. You can see it will ask where this TCS, this assembly will be applicable. That will give in this. Then click on apply. It will rebuild the corridor. Now, then after it, the corridor will be generated. Okay. I think all of you understood what is corridor assembly. So we will stop now. If anyone have doubts, please ask. Okay. Then we will stop today. Thank you, everyone.
Thank you sir.